This is a video on switching the order of integration. The question states, switch the order of integration for the double integral from 0 to 2 and 0 to x squared of f of xy dy dx. So I want to switch to dx dy, and right now I have dy dx, which means these inner limits represent functions y equals a function of x. So this is y equals 0, or the x-axis, and this is y equals x squared, which is a parabola. And the farthest left is 0, and the farthest right is 2. So let's sketch the graph. So I put my little man in, standing up since it's dy dx. The little man's feet are at y equals 0, the x-axis, and the little man's head is at y equals x squared, which is a parabola. And the little man can walk as far as 0, and that's where they intersect, so there's nothing new to draw there. And the little man can walk to the right as far as x equals 2, and that is a new boundary. So I do put in x equals 2 as this boundary. If I want to write dx dy instead of dy dx, I take the little man and I've set him horizontally instead of vertically, so that the little feet are on the parabola and the head is on this vertical line. Since I want dx dy, I can't have y in terms of x, I need x in terms of y. So I solve, and I get that x is equal to root y. Notice it's positive root y because the little man's feet are in the first quadrant. That means that x is positive, so I pick the positive instead of the negative root when I take a root of both sides. So now I'm ready to write down the double integral that has a dx dy instead of a dy dx. So I look at the little man's feet for the inner limit, and that's at the curve x equals root y, and the upper bound of the inner limit will be where the man's head is, which is at x equals 2. For the outer limit, instead of how far left and how far right the little man goes, I look to see how far down and how far up the little man walks. The little man starts at y equals 0, and we'll go all the way up to y equals 4. So I get the integral, and the inner limits are root y to 2, because that's where the feet and the head are, and 0 to 4, because that's the lowest the little man gets, and the highest the little man gets. So I can conclude that switching the order of integration results in the double integral from 0 to 4 and root y to 2 of f of xy dx dy. And I'm done with the problem.